Hello everyone. Welcome back to our channel. Today, we're going to continue exploring some interesting problems involving logarithms. In this problem, we are given a real number x, with certain conditions. X is not equal to 1 over 2, and not equal to 1 over 20. It satisfies the equation shown on the screen. Our goal is to find the value of this real number x. On the left-hand side, we have a logarithm with base 20x, and argument 22x. On the right-hand side, we have a logarithm with base 2x, and argument 202x. Notice that the variable x is completely trapped inside both arguments, 22x, 202x, and both bases, 20x, 2x. At first glance, this problem looks quite challenging. So, how do we approach it? Let's think about it for a moment. Okay, let's tackle this step by step. We'll make sure you fully understand each stage, the concepts, the methods, and the reasoning behind them. That way, you'll be able to handle more interesting and similar problems on your own. Step 1. Rewrite the equation using natural logarithms. Let the value of each logarithmic expression be k, as shown on the screen. Using the change of base formula, we can express both sides in terms of natural logarithms. This gives us a new, simplified equation written entirely with natural logs. Step 2. Apply the property of equal ratios. There is an important property of proportions. If two ratios are equal, then their common value is also equal to the ratio of the difference of their numerators to the difference of their denominators. For example, 6 over 9 is equal to 4 over 6, and their ratio of the difference of their numerators to the difference of their denominators is equal to 2 over 3. Now let's apply this property to our equation. We identify a, b, c, d, as shown on the screen. Each of them can be written as a constant plus the same logarithmic term, log x. Once these expressions are set up, we can compute the value of the ratio k. When we do the numerator calculation, the log x terms cancel out. As a result, we obtain the numerator, a minus c is equal to log 11 over 101. When we do the denominator calculation, the log x terms cancel out. As a result, we obtain the denominator, b minus d is equal to log 10. Step 3. Determine the value of the expression. Substituting the calculated numerator and denominator into the ratio for k, we find that k is equal to log 10, 11 over 101. Note that this result is expressed in base 10 after we do the change of base formula in reverse. Step 4. Set up the equation for log x. Now let's return to the left side of the original equation, as shown on the screen. Using the natural logarithm and the change of base formula, we can rewrite this expression in the form displayed on the screen. Step 5. Solve for log x. Rearrange the expression to isolate log x and we obtain the value of log x. Step 6. Substitute k and simplify. Substitute the value of k into the expression for log x, obtained in the previous step. This results in a complex, nested logarithmic expression. Through algebraic simplification, we can rewrite the exact value as shown on the screen. Step 7. Approximate the value. Now let's evaluate the real number x numerically. The numerator is approximately 13.76. And the denominator is approximately minus 4.52. Therefore, log x is minus 3.04. Finally, this gives us a numerical value of x, 0.0478. So, while the final expression for x is exact, the actual value of x is a specific, complex irrational number, approximately 0.0478. Okay, we've finally solved the problem. So, what's the key insight here? The problem becomes simple once you use two ideas. Number 1. Logarithms turn multiplication into addition, letting you separate the variable x from the constants. The problem looks difficult because x is trapped inside the arguments, 22x, 202x, and the bases, 20x, 2x. The insight 1 ensures when you switch to natural logs, base is the natural number e, the variable x separates completely from the constants. Number 2, equal ratios stay equal when you subtract numerators and denominators by the same amount. Specifically because the variable term is plus log x in both numerators and both denominators, the insight 2 ensures when you subtract them, the variable disappears. We've created a 1-minute video that explains the 2 key insights in detail. If you're not interested, feel free to skip it. Otherwise, let's start the video. In summary, this problem may look like a messy equation in the variable x. But at its core, it's really about structural symmetry. What do you think about the problem, the solution, and the key insight? Leave a comment below, and don't forget to like, share, and subscribe for more fun math problems.